So today we're going to use transformations to graph functions, okay? So up here you can see the letter C, or sometimes you see a number. All that is just a number to help us with that. So if I take a function and I add a number to the end of it, what does that do to my graph? Yeah, that's it. So if there's a number on the outside, it moves up. Well, that was an easy one, right? Okay, so the one underneath it then would move it down. Now, up and down. That is our vertical shifting, right? That's our vertical shifting. And notice when it's plus C, I do exactly what it says. I move up that far, or if it said minus C, I move down that far. So let's stick with the number on the outside, because that number's on the outside. Let's go down to these bottom two. This one here and this one here. When there's a number being multiplied by the function, which letter do you think it would change, the X or the Y?
X.
Not the X. Remember, this one here is on the outside, right? Moving up or down affects which letter? Affects the Y. So this would also affect the Y. And what I would do, if there's a number on the outside like this, is I would multiply the Y's by 3. So anytime there's a number on the outside being multiplied, it also affects the Y. So in this case, I would multiply the Y's by 1/3. So let's talk a little bit more about these. Vertically, 3 does what to the whole graph? This is my graph. It does, stretches it, right? It stretches vertically. Stretches vertically. Okay? So both of those stretch vertically. The top one actually stretches up, where the bottom one kind of shrinks it down instead.
Which one's the one? Like, which value is the one?
If I gave you a point, 3, 2, that would be your Y. You'll see an example where I go through
Oh,
specifics.
it's not going to be like that.
No, I'm going to show you specifically what I'm looking for here in a minute. But I figured this way at least you could see, okay, this affects this part of the graph. So what if it's inside parentheses?
It moves the X left to right.
Yeah, exactly. And in this case, if it's plus C, I move it to the, not to the right,
Left.
left. I always do the opposite of what I think. So in this case, I'm going to move left C. However far C is. If C is 5, I'll move left 5. Okay? And in this case, I'm going to move right C. Okay? So once again, if it's a number on the inside, I did the opposite, right? Hey, notice these 3's and this 1/3 is also on the inside. So, I need to erase that point that we talked about. Since the number's on the inside, it still has to affect which letter? It has to affect the X, just like this did, right? It affected the X. So I'm going to put an X beside there. And see how I did the opposite here? I'm going to do the opposite. So instead of multiplying my X by 3, I'm going to divide it by 3. And for the bottom one, instead of multiplying my X by 1/3, I'm going to multiply by 3. I think that's a much easier way. I'm what? Well, it says 1/3 times X. So technically I'd be dividing by 1/3, which is the same as multiplying by 3. So 1/3, what's it do to my graph? This is my graph. It would stretch it, right? So a fraction on the inside will stretch the graph. Is that how I spell stretch? Nope. There we go. Stretch horizontally. Or if it's a whole number, it would shrink horizontally. Okay.
Why is it divided by 3 and then multiplied by
I could also do multiplied by 1/3 here. I could use the reciprocal. Yeah, that would be fine too.
Right, so you increase the 1/3 and that bottom will be.
Yep,
So we can also take reciprocal.
that would be fine. And multiply. So now I've got 2 left. Okay. And this one right here, negative f of x, you've seen before. Such as negative x squared, negative x cubed. What does it do to the whole graph? Let me put a negative sign in front. Not over the y, over the x. Okay, so it flips it over the x. Now, I'm actually going to show you something that will help a little bit more than having to memorize flips over x in just a second. So, if it's on the inside, then it has to flip over the y. Any questions? So all these pieces here are separate tiny pieces, right? And very seldom will you be given an equation that says like x squared plus 3. Instead, you're going to be given a giant equation that says y equals negative 3x squared plus 7 or something, where you have to do some multiplying, you have to do some moving around, stuff like that, right? So let's do a practice problem with that. I've got a graph on the next page here, and I've got an equation. Go ahead and draw this graph on your lovely piece of paper. And notice all my graph is are dots. I'm going to connect them real quick with lines. There, 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 and there. Kind of a V-ish, right? Kind of. So make sure those points are on the points I have, and write down that equation, and I'll show you exactly what to do. Okay, so I asked you to write down those ordered pairs, so I'm going to write those down right here. Negative 6, comma 6. I've got negative 2, comma 1. I have negative 8, comma 0. 4, comma 0. And 6, comma 4. Do you guys agree with those? I'm just asking because if I made a mistake. Ah, good call. 0, negative 8. 0, comma negative 8. There we go. Okay. So now that I've got this, what we need to do is we need to make a decision. You want to talk about the outside numbers, the 3 and the 5, or do you want to talk about the inside? Which one do you want to talk about, Trevor? Doesn't matter. Outside. Okay. Outside. Now, according to my order of operations, so I'm only talking about the outside numbers, and I have to do both of them before I talk about the inside numbers. Okay? According to my order of operations, what thing do I have to do first? Parentheses, exponents, then I multiply, right? So the first thing I must look at then is this 3, because my order of operations tells me I must look at that 3. So if 3 is on the outside, what did we write down in our notes to do if there was a number on the outside? Multiply what? The y's by 3, right? Okay, so I'm going to make a new set of ordered pairs here. I may have to do this a couple times, but you just said multiply the y's by 3, right? 6 times 3 is 18. I'm writing that tiny because I'm going to do something else to the y's here in 1 minute. Okay? 1 times 3 is 3. Negative 8 times 3 is 0 times 3 is? 4 times 3 is? Okay. So all I did was multiply my y's by 3. Now, according to the plus 5 on the outside, what do I do to all of my y's still with the plus 5? Up 5, right? So if I add 5 to 18, what number do you get? 23? You see how I just added 5 to those numbers? Or that number? I'm going to add 5 to 3. What number do you get? 8. 5 to negative 24 is? Negative 19. 0 plus 5 is? 5. 12 plus 5 is? 17. Those are my new y values. I just found them. Now, I know they look a bit crazy. Leanne's looking at them and she's like, 23, negative 19, they don't fit on my graph. That's true. I made up the graph, Leanne, so it may not be pretty. Okay? And that's going to happen sometimes. So we're just going to have to make it fit somehow here in a minute.
I thought you were supposed to take the reciprocal and then multiply. So what
You
if they
use
want-
the reciprocal when the number's on the inside. Okay, so if the number's on the inside, then you use your reciprocal.
Oh, so this is the thing. That's a little more. I put take reciprocal and multiply the
For if the number's on the inside. If the number's on the outside, it's just multiplied by that number. Exactly what you would do, right? Okay, so now we've dealt with the outside because that's what Trevor wanted to deal with. Honestly, he could say inside or outside, we're going to get the same answer. So now we're going to work on the inside. Well, on the inside, we do everything backwards, right? That minus 4 actually means move to the right 4, okay? In the order of operations, say to do multiplication before you do addition or subtraction, but I just told you, do everything backwards, right? So the very first thing I'm going to do is the minus 4 part first, because I got to work backwards. What does that mean I do to all of my x's? I add 4. So negative 6 plus 4, negative 2 plus 4. Oops, I shouldn't write that large, because I have to do a little bit more to it, right? 0 plus 4, 4 plus 4, 6 plus 4.
Where did you get to do everything the opposite side? Or is that just like a law?
That's like the law for that part. That's an easy way to remember. Mainly because if you remember that negative 4 already moves it to the right 4, and that's opposite of everything we've ever been taught, right? So if that moves it to the right, positive 4, that means I have to do the opposite the whole way through. Okay, so I'm using that whole opposite theory for the whole thing. So now I'll deal with the 2. Now, Ryan, this is where I'll use that 1/2 instead. I'll multiply by the reciprocal. So, what is negative 2 times 1/2? Negative 1? 2 times 1/2. 4 times 1/2. 8 times 1/2. And 10 times 1/2. So, like I just told you, I made up this problem, right? I purposely made sure I went on to even numbers so that I could get nice whole numbers there, but I didn't quite look at the y values. Oops. So now let's regraph this. Let's graph our new function. I used the reciprocal of 2. Okay? So now let's graph this. Negative 1, I'm going to change colors so we can see this. Negative 1, comma 23. I think that's 23 up there. What do you think? You okay with that being 23 up there? No? We're going to go with yes. All right, 1 comma 8. So here's 1, here's 8. Okay, that one's there. 2 comma negative 19. That's way down here. It's actually even further down, I would assume. But we're going to pretend. 4 comma 5. 4 comma 1, 2, 3, 4, 5. And 5 comma 17, not as high as 23. Okay, and now I'm going to connect them. 1 there, way down there, way up here, way up there. So I tried to fit those on my graph. I'll give you a minute as you're copying that down, so then we can talk about it to make sure it makes sense. Yeah. Okay. So now let's make sure this makes sense. Okay. This +5 moved it which way? The +5 on the outside moved it up, right? Okay. But the 3 then took that +5 and it stretched it this way. Does it look like it's been stretched? Okay. This 2 right here, actually, does it increase it horizontally or decrease it? It decreases it. So notice how now it's no longer this long, it is shrunk and it's half that size. You see that? So that's how I get those numbers. Now, if it had been a normal equation, so if I had a normal equation, let's go with the cube problem. I would actually do my equation, my graph the exact same way. I would write down those 3 points right there and do exactly what I just did with that chart. It works every single time. It makes it so much easier, doesn't it? Than trying to say, I'll move it this far and then I'll move it this far, trying to put those dots on there and messing up the dot. So instead, if you write down your points and then you change them, just like I told you, it will always work. So, I've got a couple problems for you guys to try. So I'm actually taking 2 days on today's lesson. Okay? Tomorrow we'll deal with the basic equations with that. But for today, we're just going to practice what does what number do. You guys are going to get that practice with some points.